14 years, 27 deaths, and one family's obsession created what the world called impossible.
78 feet beneath the East River, men worked in darkness where no human had ever survived.
600 workers descended into pressurized chambers, breathing air compressed to double normal atmosphere.
Watch as one man's vision transformed the impossible into the eighth wonder of the world.
Engineer John Roebling designed his masterpiece to be 8 times stronger than necessary, then died before laying a single stone.
At the Greenpoint shipyard, master craftsmen built the largest caisson ever attempted, a bottomless box to conquer the riverbed. Tin sheathing protected against fire, while 6 internal chambers enabled men to work and materials to flow.
On March 9, 1870, the Brooklyn caisson slid into the East River, 3,000 tons of hope and timber.
Against fierce currents, tugboat crews positioned the caisson with inch-perfect accuracy over the foundation site.
As granite courses rose above, the caisson's immense weight forced it downward into the riverbed.
In stifling heat and double atmospheric pressure, sandhogs carved through 44 feet of riverbed.
Water-filled tubes carried excavated debris to the surface, allowing the caisson to sink inch by inch.
Above water, the Brooklyn Tower rose, limestone and granite courses adding weight to push the caisson deeper.
Twin operations worked in perfect sync. Every stone above pushed workers deeper into darkness below.
Within weeks, carpenters replaced damaged sections and strengthened the caisson beyond its original design. At 44 feet, workers struck foundation-worthy material. The Brooklyn caisson's journey downward was complete. Rosendale cement and limestone aggregate transformed the wooden box into 6,000 tons of permanent foundation. On solid foundation, the Brooklyn Tower rose toward its full height of 278 feet. The Manhattan caisson incorporated every lesson learned, 22 timber layers and iron fire protection. The Manhattan caisson, the largest ever built, entered the East River to face its deepest challenge yet. Off the Manhattan shore, the caisson took position for a descent twice as deep as its Brooklyn sister.
Every foot deeper doubled the danger. Pressure at 78 feet compressed air to 35 pounds per square inch.
Washington Roebling spent countless hours below, personally supervising, unaware he was destroying his own health.
78 feet down, pickaxes finally struck Manhattan bedrock, the deepest any human had ever worked underwater.
6,700 toes of concrete transformed the wooden box into the world's deepest underwater foundation.
Twin Gothic towers rose from both shores, 278 feet of limestone and granite defying gravity.
Gothic arch keystones locked millions of pounds of stone into self-supporting structures of perfect balance. At full height, the Brooklyn Tower became the tallest structure in the Western Hemisphere.
By 1875, both towers stood complete, each containing over 46,000 cubic yards of masonry.
60,000-ton anchorages would grip cable tension equivalent to the weight of 25,000 automobiles.
Iron anchor plates weighing 46,000 pounds each would grip the cables for centuries.
Towers and anchorages stood ready, the stage set for the most daring construction phase of all.
August 1876 marked the first physical connection between shores, a single rope to birth 4 mighty cables. Roebling's parallel wire method would spin 5,000 wires into cables stronger than any rope could achieve.
Day after day, the traveling wheel carried individual wires across the span, each precisely positioned.
Galvanized steel wire from Sheffield, England, underwent rigorous testing, strength of 160,000 psi required. 19 strands combined into each cable, 15 3/4 inches of pure tensile power. Wrapping wire compressed and protected each cable, creating a weatherproof sheath for generations.
1,500 vertical suspenders and 400 diagonal stays created a web of support unlike any bridge before. Steel trusses 33 feet deep would provide stiffness no suspension bridge had ever achieved. From both towers, the deck extended toward mid-span, each section precisely calculated for weight and balance. At mid-river, the two deck sections joined, the 1,500-foot gap finally closed. An elevated promenade offered pedestrians a grand walkway above the traffic, a park in the sky. The Manhattan approach stretched 1,500 feet, descending from river height to city streets.
Brooklyn's approach incorporated 9 separate bridges, allowing traffic to flow beneath the grand entrance.
Granite paving stones and railway tracks transformed the steel skeleton into functioning roadway. Gas lamps would illuminate the crossing, America's first bridge lit for nighttime travel. Protective paint in Brooklyn Bridge tan sealed steel against the corrosive East River air. Toll booths in matching Gothic style would collect fees to repay the bridge's $15 million cost.
14 years of labor culminated in final preparations. The eighth wonder awaited its unveiling.
Emily Roebling claimed the first crossing, the woman who made her husband's vision reality. May 24, 1883, the day two cities became one across the world's longest bridge.
President Arthur, Governor Cleveland, and 50,000 citizens gathered to witness engineering's greatest triumph.
Speakers proclaimed the numbers: 14 years, $15 million, and countless acts of courage. President Arthur led the first official crossing, the nation's leader walking into engineering history.
As darkness fell, over 1 million people had crossed. Now the celebration reached its climax. 14 tons of fireworks celebrated the birth of what newspapers called the eighth wonder of the world. The morning after, Brooklyn and Manhattan were no longer separate. They were one city, connected.
From his bedroom window, Washington Roebling watched his family's legacy carry a nation forward.
6,000 feet of innovation, every measurement a testament to human determination over nature's obstacles.
Year after year, the bridge carried more than its designers ever imagined. Adapting, enduring, essential. The bridge became more than infrastructure. It became a symbol of what America could achieve.
Every major suspension bridge that followed borrowed from John Roebling's revolutionary design.
Generation after generation maintained the masterpiece, replacing, strengthening, but never rebuilding.
140 years later, the Brooklyn Bridge still carries a city, stronger than the day it opened.
Every stone, every rivet, every cable speaks of craftsmen who built to last centuries.
From dream to stone, from tragedy to triumph, the Brooklyn Bridge endures as America's greatest engineering poem.
From the depths of the river to the heights of imagination, the journey from foundation to forever.
Every detail perfected by hands that understood their work would stand for generations. Built by hands, tested by time, eternal in stone and steel. Sheffield steel galvanized by methods now lost, these original wires have outlasted modern replacements.
Bedridden but brilliant, Roebling calculated every stress, every load, every critical measurement.
Cable saddles distributed millions of pounds, every position calculated to the fraction of an inch.
Beneath the anchorage, the Blue Grotto stored wine at perfect temperature, infrastructure serving commerce.
Summer to winter, the deck expands 16 inches. Roebling designed for every condition.
Modern technology inspects cables roebling, designed to be examined without destruction.
Forces flow through redundant paths. Roebling's genius created a bridge that cannot fail.
3 names forever linked: a father who dreamed, a son who suffered, a wife who completed.
At night, the bridge becomes pure geometry. Lines of light spanning the darkness between shores.
52,000 sunrises have illuminated these towers, and 52,000 more await.
From this point, every view tells 2 stories: the city that was and the city that became.
6,000 feet of stone, steel, and wire, built to outlast the generations that will cross it.
The impossible made eternal.
Ever wondered how the modern world was built? It was shaped by engineering. Subscribe to Industrial Evolution.